Yes, students. So in this third part, I'm going to talk about again, I'll show you some of the videos related to the process. Before that, I'll give you a quick overview that again, in the first step, you can see that the powder is deposited. Then the inkjet applied the binder. The print head is putting the binder selectively in the regions. Then each layer is printed as a result of this thing. Here again, another layer of powder is placed. The process is going to repeat itself, and that's how the 3D process will get complete. So this is just like a quick overview, and then we'll go to the next part where I'll show you some of the uh, videos related to the process. So let me go. So this first process is introductory process related to the binder jetting, and let's look into that.
Binder jet 3D printing is one of the fastest and most production-ready forms of additive manufacturing. Binder jet uses an industrial inkjet print head technology to quickly deposit a bonding agent onto a thin layer of powdered particles. Anything from sand, a variety of industrial ceramics, more than 20 metal alloys, and even wood. This high-speed process is repeated layer by layer using instructions from a digital file, using only the material needed to shape the part until the object's form is complete. What makes binder jetting production ready is its mature and stable process. The strategy of depositing binder across a powder bed with the sweep of a print head is like printing on paper. Compare that to other 3D printing techniques that use points or lines to trace out an object. The speed of binder jetting is unmatched. With each fast pass of the print head over the powder, complex geometries are formed, removing many of the design constraints of conventional manufacturing methods. After the print process completes, the powder bed is then dried or cured in an oven. The post-print process will depend on the materials being printed and the complexity of the geometry. The print process results in a green part created from bound particles. The printed parts, or green bodies, are then removed from the powder bed through a process called depowdering, recycling most of the material not printed. For most metals, those green bodies are then further cleaned prior to sintering in a high-temperature furnace. Sintering fuses the metal particles together into a final metal object that is dense, accurate, and can be machined. The speed of Desktop Metal's Binder Jet 3D printers makes complex parts more affordable than any other form of metal 3D printing.
Yeah, so students, this was a very good introductory video. I'll have some more, so I'll show it to you now.
Binder Jet 3D printing is one of the fastest and most production-ready forms.
I think this is the same one. I need to put the second one. This is the second one, yes.
These two production steps are repeated. Again and again. And again and again, until the desired object is built layer by layer. After the printing process is completed, the loose molding material is removed. The printed parts can be extracted, and no matter how complex they are, finished during an easy post-process. Binder jetting. X1's 3D binder jetting technology offers new business options for the foundry industry. For individual parts, for small series, and for serial production of complex parts. With innovative production alternatives in many high-growth industries. With ideal material utilization, also for metal printing and ceramic printing. Welcome to X1.
So students, X1 is one of the major supplier of this technology. So this was from them, and now I'll have one more introductory video that you can see.
Binder jetting is an additive manufacturing process for metal, other materials too, that involves no melting. It's becoming increasingly important as a broader range of manufacturers applies additive to part production. I'm Pete Zielinski with Additive Manufacturing Media.
And I'm Stephanie Hendrickson. In this video, we'll talk about what binder jetting is, how it works, materials and applications for this process, and potential advantages of using it.
Stephanie, start us off. What is binder jetting?
Binder jetting is a 3D printing process. It's one of the 7 families of additive manufacturing technology, and it involves dropping a liquid binder onto a bed of powdered material to build up what is usually called a green form.
So, the starting point, a bed of powder material, could be metal, might be non-metal, we'll get to that in a sec, but a print head goes across this powder bed, jetting a binding agent. Jetting a binding agent in the 2D shape of that particular layer of the part, that cross-section of the part. It's sintering that completes the process, and the sintering step turns that green part into a fully dense, fully solid, strong, hard metal part, if metal was the material. But let's talk about that. What materials can be used in binder jetting?
So binder jetting is probably most commonly associated with metals, and it can be used with a variety of those. So cobalt and nickel alloys, aluminum, stainless steels, lots of precious metals. But as you hinted at, binder jetting is also compatible with other types of materials, including ceramics like carbide and even sand. So what types of applications exist for binder jetting?
So there is no one particular industry or application that is best known for binder jetting. Instead, binder jetting is being applied broadly. This is a relatively productive, cost-effective 3D printing process for production, and it's succeeding in manufactured parts like machine components or fittings, metallic filters, even wear components made out of hard materials like carbide. You mentioned sand also. So in foundry work, in casting, metal castings are formed oftentimes using cores and cavities made of sand. And those cores in particular can be 3D printed through binder jetting. More complex core forms realized more cost effectively thanks to binder jetting of sand. So range of different possible applications, different possible parts that could be made this way. But when a part is made this way, what comes next? What post-processing is involved?
So at the end of the printing process, all of those delicate green parts are going to be encased in the excess material. So the first step is going to be to get those parts out, to gently remove them and remove any excess powder. If you are printing with sand, making that foundry tooling, that's probably all you'll need to do. That tooling is going to be pretty much ready to go off of the printer. But for metal and ceramic parts, there's going to be a few more steps, notably the sintering process. So your parts need to go into a sintering furnace where they're going to be heated up and fused together to form those fully dense final parts. Sometimes parts might need to go on for additional processing like hot isostatic pressing for improving their material properties, or oftentimes finish machining. Let's talk about reasons to use binder jetting.
There are a lot of them. It is a way to 3D print in metal without melting. And so that expands the range of metals that can be easily 3D printed, and 3D printed in a more controlled process because there's no phase change.
Because there's no melting in the printer, that also often means you don't really need support structures. The parts are going to be supported by the loose powder during the build, and you can nest them in 3 dimensions, so you can pack a lot into a single print.
Binder jetting is a way to 3D print with very hard materials, particularly materials that might be prone to stress cracking in a different additive process that involved a big temperature change.
Another advantage of no heat being applied during 3D printing is that any of that powder that wasn't touched by the binding agent is essentially the same material coming out of the printer as went into it in the first place. So recycling and reusing the material becomes a bit easier.
Binder jetting is relatively productive and low cost compared to other methods of additive manufacturing for production. It runs unattended, and the lower cost per part brings production 3D printing to a broader class of potential production parts.
Binder jetting is also closely related to some more conventional manufacturing processes like metal injection molding, or MIM. So if you have a furnace that's suitable for MIM parts, chances are you can probably use it for binder jet parts too.
To learn a lot more about binder jetting, including examples of parts that it is succeeding with, see the links in the episode description or visit our website, additivemanufacturing.media.
Thanks for watching.
So students, if you have seen this video, you will see that they're talking about the advantages of this process, and one of the major advantage of this process is linked with that during the printing process, no heat is involved. Once the prints are ready, then you keep it in the sintering environment separately in the sintering furnace. But during the printing, you can put materials, metals, very easily in the certain geometry, and regardless what you have seen in the powder bed fusion or the DED systems where high temperature thermal gradients are involved, this is not available in this process, which means that many new materials, many different materials which are prone to stress cracking, they can be printed this way. So this is the part. Now I'll explain the remaining in the next part.